Hello everyone, my name is Abhishek and welcome back to my channel. Today is episode 15 of Azure Zero to Hero series, and this video is part 2 or continuation of the Azure DevOps project that we were doing. So in the part 1, I have implemented continuous integration for this project. Just to give a very quick recap, this project is developed by Docker Samples organization by Docker team, where this is a multi-microservice architectured application where there are 3 microservices, each written in different programming language, just for the purpose of demo, so that people understand containers in a better way and interaction between the containers in a much better way. So one microservice is written in Python, one in .NET, and one in Node.js. Along with that, there is also Redis, which is in-memory data store. And then there is Postgres, which is a database. So the workflow of this application is pretty straightforward. So when you run this application, right now this application is running on my Kubernetes cluster. When you run it, so you get a poll or a voting option between 2 options. So right now the options are cats and dogs. Like if I select one option, let's say, so I picked up cat. So this instruction is stored in Redis. From there, the .NET application picks this information from the Redis and stores it in the database. That is the Postgres database. Finally, there is another results microservice. Right now, it's not started. But when you go to the results microservice, you can see how many people have opted for cats and how many people have opted for dogs. So it's a pretty straightforward voting application. Now, what we will do in today's video, right? In the last class, we migrated this entire application from this GitHub repository to the Azure DevOps. So I moved the entire setup to the Azure repos where the complete source code is moved. And also we have set up pipelines for all the microservices. And also we have pushed the images to the Azure Container Registry. So if you go to the Azure Container Registry and look at the repository section, so for 2 microservices, I have also implemented Azure Container Registry. So results app related images will be available here and voting app related images will be available here. So this is what we have done in the last class, the complete CI part, which is just building the image and pushing the image to the Azure Container Registry. I hope this is a very good quick recap. And what I will do today is I will set up the continuous delivery as well. And for the continuous delivery, we will use GitOps approach, right? So GitOps approach is the modern way of doing continuous delivery. We'll not be using Ansible playbooks or we'll not be using shell scripts for the deployment, but we will use GitOps where there are so many advantages. I'll talk about it and I've made a lot of videos anyways, but even in today's video, I will explain why I prefer GitOps over the other deployment models. So I'll give a very quick demo and then I will explain the complete continuous delivery model, how to set up this configuration, each and everything. But I think if I show you the end-to-end CI/CD demo first, it will be much easier for people to understand what we are implementing. So right now it is cats versus dogs, right? This is the option. So now what I'm going to do is I will go to the source code and I will go to the vote application. Let's say I'm a developer. And what I'm doing is I'm changing the opinion poll. So it's a basic Python Flask application where the app.py has the options and there is a template, the HTML file. And these options are rendered into that HTML file and the one that you see here. So as a developer, let's say I'm a developer and I will just go to the app.py file and I will modify these options, right? Right now you are seeing the options as cats versus dogs and I'll click on the edit button, change this to, let's say, summer, winter. And as soon as I commit, right, my CI/CD should trigger and it should perform the end-to-end continuous integration and delivery. I've already done it. So for the purpose of demo, I'll show it. And then I will reconfigure the entire CI/CD for you. Don't worry about it. So now I've changed the options to summer and winter. Immediately, the pipelines are triggered. If you see here, so the pipeline right now has 3 stages. This is the new stage that I've added, right? But Abhishek, you said we will not be doing continuous delivery using the Azure pipelines. You said we will be using the GitOps approach. Yes, this stage is doing something else, which I will explain. So the build stage and push stage is something that we have demonstrated in the last video itself. Now, if you go to the build stage, so build is running and it is successful. Image is built. Now the push stage is going on. As soon as the push will be done, I think it is going on. Let's see. Yep. Push is under preparation. Okay. Now push is also done. Perfect. The image is pushed. So if I go to Azure Container Registry to the voting app, now I should see a new version, right? If I refresh, uh, I should see 61. Yes. So it is just pushed. Perfect. And now there is this component called Argo CD, which is performing the GitOps part. And Argo CD should pick up this new change. If you just refresh this, you should see that Argo CD is already working on publishing this new change to my Kubernetes cluster, right? So yes, succeeded a few seconds ago. So even it has performed the deployment. Now, if I refresh this page, I should see the new option, summer, winter. Perfect. So this is how end-to-end CI/CD is done. And what are the components that are working here, right? If we try to understand the components, I'll also explain this using a diagram. But for now, if you try to understand, right? So firstly, as soon as the developer made the change, Azure pipelines triggered. And what Azure pipelines did here, there are 3 stages in the Azure pipeline. One is build, which we all know, creation of Docker image. Next is push, where the image is pushed to the Azure Container Registry. Then there is this stage called update. So what exactly update is doing? So if you go to the repositories, I have this shell script here, update k8 manifest.sh. What exactly it is doing is it is updating the image version in the K8 specification section, right? So the old deployment.yaml is updated. If you see here, the tag is changed to 61. So automatically the Kubernetes YAML manifest is updated to the new version, and Argo CD, which is monitoring this particular folder and this particular deployment file, realized that there is some change in Git, and it automatically deployed the new version onto my Kubernetes cluster. So if I go to my Kubernetes cluster, so this is my cluster where all the pods are running. kubectl get pods minus n Argo CD. I'm deploying it to that namespace. You can deploy it to any namespace. And see, the oat pod age is 118 seconds and others are like 2 hours, 3 hours. That means the oat deployment is just created, or the pod is just updated with the new image. So this is how the end-to-end CI/CD is performed. Now this was the demo. Now let's look at the configuration part, right? Right from scratch, creation of Kubernetes cluster, Argo CD, configuration, everything I'm going to show in today's video. So please try to watch it till the end. Perfect. So now I have deleted the scripts, reverted all the changes related to continuous delivery in the Azure pipelines, and I have also deleted the Kubernetes service. So all the continuous delivery related configuration that I have done to just show you the demo preview is removed. And let's do all the configuration changes right from the scratch. So the first thing that we will do is create a Kubernetes service, because it's going to take a lot of time, right? So I will create the Kubernetes service, and while this is getting created, parallelly, I will explain you the complete workflow that we are doing today. What is the continuous delivery process, how GitOps comes into picture, what are the advantages that it will add. We will try to understand everything through a whiteboard, but let's first create a Kubernetes cluster. So for that, what I will do, click on the create button, create a Kubernetes cluster. We are using Azure Kubernetes Service, that is AKS, in this video to create a Kubernetes cluster. We will discuss more about AKS. We will perform a 3-tier architecture on the AKS. So we will do deep dive on AKS. Don't worry about that. But because I want to use Kubernetes as a target platform in this particular demo, just that the entire CI/CD project is complete and adds a lot of value for you in your resume. That's why I'm choosing AKS in this video. Otherwise, I could have easily demonstrated this on a virtual machine as well, which is quite easy for me. But I wanted to do it on Kubernetes so that you will learn end-to-end continuous integration and delivery on a Kubernetes cluster. So let's go back and choose the resource group as what we were using throughout the demo, Azure CI/CD. Cluster preset configuration. Yeah, let's use the dev test. Basically, Azure provides different preset configurations. If you are running some demos or if you are doing some proof of concepts, use the dev test. Whereas if you are running your production workloads, you should be going with either standard economy or enterprise. Cluster name, let's call it as Azure DevOps. Region, I'm using US West 2 region. The reason for that is I'm running into some resource quota issues on the US East. So if you are also running into some issues with respect to your resource quota, just change the region. Availability zones, let's pick up one of these zones. Kubernetes version, yeah, I'm fine with it. And these are some advanced capabilities that AKS brings you. Instead of using a self-managed Kubernetes cluster, there are some very good advantages of using AKS, that is Azure Managed Kubernetes Service, which are these concepts. We will learn them in detail when we deep dive into AKS. Click on the next button and you can use your agent pool, right? So why we need agent pool? The reason for that is AKS is just a managed Kubernetes service, but to run your workloads, to run the system workloads, which are nothing but the pods and your applications, you need a virtual machine. And this pool actually provides you that resources for the compute. So what I've done is what I'll be doing is I'll just go to this node pool, which is pool of virtual machines for your cluster. So what I will do is I will modify this configuration little bit, where I will say the minimum node capacity as 1 and the maximum node capacity as 2. What exactly is this? Basically, when you select the scale method as auto scale, you will be using the virtual machine scale sets feature or auto scaling feature of the Azure, where the Kubernetes clusters can be scaled automatically. The Kubernetes nodes can be scaled automatically. That means if your Kubernetes cluster is set up with one node initially, when there is more traffic that is coming at your Kubernetes cluster or to your applications, then the virtual machine scale sets will automatically scale your Kubernetes nodes to 2. If I select this as 10, it will scale that automatically to 10 if required. But better keep it in the limit. The reason is that in some cases, when your firewall is breached and if some hacker is able to access your cluster, your applications, then they can perform some denial of service attack. And if you are just scaling it to some, numbers like 10, 20, 100, your application withstand the hacker attack, the denial of service attack, where hacker is sending 1 million requests to your application. Your application might withstand because you have enabled auto scaling. But the problem is you will be charged very, very heavily by Azure, right? So that's why I will keep it to a reasonable number, 1 and 2. Maximum pods per node, the minimum is 30, and in my case, I don't need more than 30. Enable public IP per node, yeah, because we are going to expose the service in node port mode. Now let's say create, select the agent pool. You can also select multiple agent pools where you can set one agent pool for the system workloads, that is the Azure Kubernetes service workloads, and you can use other agent pool for your workloads. You can also do that. Now I don't want to change any other feature. Click on review plus create. And this is where you will come to know if you are running into any resource quota related issues. So initially when I was trying to do this in the morning, I ran into some resource quota issues on the US East region or East US region. So I changed this entire thing to the West region, right? You can also do that. Click on the create button. So now this will create my Kubernetes service or the Kubernetes cluster, and it will take some time, right? So submitting deployment, this might take some 10-15 minutes. So you need to wait if you are performing this demo along with me. What I will do is to use this time effectively. I will explain the entire workflow that we are doing while the cluster is getting created. So in the last class, we have implemented continuous integration where we have performed the build stage, which is Docker image creation. Once the Docker image is created, Azure pipelines automatically triggered the image push stage where the artifacts are pushed to ACR, Azure Container Registry. I could have choose the Docker Hub also, but I want to keep everything in the Azure DevOps ecosystem. So that's why I choose ACR. Now this is what we did in the last class, where this entire thing is part of the continuous integration. And we used Azure pipelines to perform this thing. This is CI, and in CI you can add other stages as well, like you can add unit testing, static code analysis, but our focus is to learn CI/CD, not to add more stages. Now, how about CD? That is continuous delivery. The typical thing that we do as part of CD is to deploy the newly created container image. Let's say there is a developer, and if this developer makes a change to the Azure repo, right? That is, developer makes any change to the source code that is in the Azure repo, which is this one. Let's say developer makes any change to this repo, then our pipeline will be triggered automatically, the Azure pipeline, and it triggers the build stage where a new Docker image is created. Automatically, it will trigger the push stage. The new image is pushed to ACR with the change that developer has made. Assume developer changed this thing to from summer winter, which is our current stage. Let's say developer has changed this to rain snow. Okay. Let's say developer wants to take the opinion between rain and snow. So this is the change that is made, and image is created with this particular change. But if we don't perform the deployment, right, unless we do the continuous delivery, this application or this change will not be live to the customers. So that is what we will do in today's video, where in CD part, we will use a Kubernetes cluster, which we are creating right now, AKS cluster, right? And as part of this AKS cluster, where the application will be deployed, so we will use the GitOps approach. In the GitOps approach, we will use the GitOps tool called Argo CD. I will prepare a very clear architecture diagram for this, and I will be uploading this in the Day-15 folder. Right now, Day-15 folder already has some notes. If I just refresh this page, so Day-15 already has some notes for your reference. I'll also create an architecture diagram. If you want to share that you have created this project, you can use that architecture diagram. It will be uploaded to the Day-15 folder while the once the video is live. So this GitOps will take the new image that is pushed and upload this to the Kubernetes cluster. But how does this happen, right? Because there is a gap here. CI is pushing the image to ACR and GitOps is actually pushing that to K8s. But how will GitOps come to know that there is a change? Obviously, the new image is pushed to ACR, but GitOps does not know it. So for that, what I will do is I will add a new stage, right? In the CI itself, I will add a new stage. This stage is called as update. And what this stage will do is the update stage will update the new image that is created to the Azure repos. In Azure repos, there is a folder called K8s manifest, right? If you look here, this particular project, the Docker team who has developed, they have created something called as K8 specifications. And within the K8 specifications, there is the deployment and service file for each of the services. So OAT has deployment and service, result has deployment and service, Redis has deployment and service. Also DB has deployment and service. So we will use this Kubernetes manifest, and the update script that I am writing here, what this update script does is once the image is pushed to ACR, this shell script will go to these manifest files, let's say the oat deployment.yaml manifest file, and it will update the image. Right now the image is set to Docker samples example oat. This will be replaced automatically by my shell script, right? And it will be updated with something like Abhishek Azure CI/CD, which is my registry name, followed by voting app, followed by the build number, which can be, let's say, 63, 64, or 65, whatever it is. So this update is made by my shell script. I have to write that shell script. And once the update is made, GitOps is always watching for the Git repository, right? And GitOps pulls this change and deploys that to the Kubernetes cluster. So how does the end-to-end system would look like? First, in the CI, we will have the build stage. Then we will have this push stage. Before that, there is, of course, Azure repo. When developer makes a change, build is triggered, push is triggered, and this is pushed to ACR. And immediately there is a stage called update. And this update will again update the same repository that you're seeing here, or you can also maintain a different Git repository. There is no problem, right? So this repository will be updated with this new image. And then we have GitOps. See, I'm intentionally not drawing any connection between update and GitOps directly, because GitOps is single source of truth, where Argo CD, or you can also use Flux, any GitOps tool, they will be watching for the repository. And once the image is updated in the repository, then GitOps will pick up this new change and deploy that to the Kubernetes cluster. So this is our CI/CD pipeline, right? So here there is no connection between CI, this is all CI, and this is CD. There is no direct connection between CI and CD, but the Azure repo, it can be the same repository as the source code or a different repository. It is acting as a connection point. Once the update script updates this particular image, GitOps will know the image and it will automatically push that change to Kubernetes. Now there are two questions here. One, why shell script? Two, why GitOps? Right? Let me answer these things. One, why shell script? Of course, there is another project that is available with the Argo organization, which is called as Argo Image Updater. But right now, Argo Image Updater is not generally available. It's not a GA product. So that's why we will not be using Argo image updater. In future, once this is GA, that is once it is stable, we will use Argo image updater in our project demos. But at this point of time, we should be using shell scripts or Python scripts, anything, because shell is very generic, and also the agent that I'm using is a Linux agent. So I prefer using shell. Using shell, the image is updated to Git. Now, why GitOps? I have explained multiple times this thing. There is also a complete GitOps playlist on my channel. But if I have to explain this in a nutshell, GitOps is basically, so GitOps use Git as a single source of truth, where in the Git repository, we will put our Kubernetes manifest files, such as the deployment, service, config map, secrets, everything. Git will continuously watch for the Git repository where the Kubernetes manifests are available, and it will deploy them onto the Kubernetes cluster. But you can do this with shell script also. What are the advantages? So there are bunch of advantages, but the primary one is continuous reconciliation. That means as soon as a change is made to the Git repository, GitOps will automatically identify the change. In our case, when a change is made to this deployment.yaml, if the image is changed to 64, GitOps Argo CD will automatically know that because it is watching for that Git repository, and it will push the image to Kubernetes cluster. This is one thing. And the primary advantage is that if someone makes any change to the Kubernetes cluster, let's say there is a person who has access to the Kubernetes cluster, and unknowingly or intentionally, this person logged into the Kubernetes cluster and changed the image name, right, in the Kubernetes cluster, not in the Git repository. So that person moved to the Kubernetes cluster and let's say change the image name from 67 to 167. And this 167 actually does not exist. So this person has created a drift in the configuration. And this drift is actually not good, because nobody should make any changes to the Kubernetes cluster. If someone is making, they have to make a legitimate change. This person has made a wrong change intentionally or unknowingly. And because of this, your application stopped working, because 167 does not even exist. If you are using GitOps, this will not be possible, because GitOps will not allow any changes to the Kubernetes cluster. If someone makes a change to the Kubernetes cluster, GitOps will say that, okay, I'm continuously monitoring for Git, and in Git, the image tag is 67. So let me revert your change and put the image name back to 67. So technically, this person can make change to the Kubernetes cluster, but that is overridden in fraction of seconds using the GitOps approach. There are so many advantages of doing this. I just took an example of image, but let's say if someone is modifying the node configuration, or if someone is modifying secrets, or if someone is modifying any important information on your Kubernetes cluster, everything can be tracked in a Git repository. Technically, you can put all your Kubernetes resources, such as your node specifications, that is the node YAML files. You can put your pod YAML files. You can put your secrets. But of course, if you put your secrets, you have to use some mechanism where there is secret management solutions. You can put your config maps, right? You can put technically all your Kubernetes cluster, admission controllers, all the configuration in a Git repository, and ask your GitOps to manage your Kubernetes cluster. So these are some principles where there is continuous reconciliation that takes place. And if someone modifies, the change is updated automatically. So drift is also detected. Not just detected, but drift is also fixed if you are using GitOps. There are more advantages. If you want to learn, you can check my GitOps playlist on the YouTube channel. And if you want to get this entire architecture diagram, I will upload that to the Day-15 folder in this GitHub repository. You can use that architecture diagram, no problem. You can post it anywhere. Perfect. Now let's see if our Kubernetes cluster is ready. I think it should be ready. Yeah. So it says Microsoft AKS, just go to the resource and my Kubernetes cluster is ready. So the first things first, what we have to do, if we write the steps of what we need to do, looking at this diagram, right? So the first thing that I have to do is get a Kubernetes cluster, K8s cluster, which I have. Now I have to log into this Kubernetes cluster as a first step. Second thing is within this Kubernetes cluster, I have to install Argo CD. Third step is configure Argo CD within the Kubernetes cluster. Fourth step is I need to write that update script, which is a shell script, right? And the purpose of this shell script is to update the repository with new image, the same image that is published to ACR. Let's do step by step. First, let's see how to log into the Kubernetes cluster, right? So for that, I'll go back, take my terminal, right? So if you have followed our previous classes, we have already set up AZ, the Azure CLI on our workstation. So I will run this simple command called AZ get credentials, right? AZ AKS get credentials. This is the command. AZ AKS get credentials, name of your Kubernetes cluster. Use this hyphen overwrite existing if you have the cluster with the same name. Resource group Azure CI/CD. Of course, not the cluster with same name, but if you have in your kube config, if you already have the configuration, then you need to use overwrite existing. So perfect. Now this will set up my terminal with the Azure Kubernetes cluster. And if I just do kubectl get pods, there should not be anything. Let's proceed with our second step, which is setting up, installing and configuring Argo CD. So for that, I will go to Argo CD official docs, Argo CD docs. And it's very straightforward. All that you need to do is go with getting started, install Argo CD, just copy this. And there are two commands. First command will create a namespace called Argo CD. Second command will deploy all the manifest resources such as the Argo workloads, controller, service, repo server, Redis, all the components will be deployed. You don't need to know the in detail architecture of Argo CD for this particular video. But if you want to understand, you know where to go. Just go to my GitOps playlist. But for this video, I think it's not that much needed. See how many resources are getting created. All these resources are just related to Argo CD. Some of these things you might not need, but when you are managing at your organizational level, then you might need all of these resources. Such as in today's video, I'll not be using notifications, or I'm not worried about metrics. To be honest, I'm not even worried about decks in today's video. Let's see kubectl get pods -n Argo CD. Okay, the pods are running. Some of the pods are in the initialization stage. Let's wait for the pods to be available. I think they should be ready now. Perfect. All the pods are running. Now, what we need to do next, once the pods are running, what I want to do is configure Argo CD. What is configure Argo CD? Like I told you, GitOps approach, there will be a Git repository. And in the Git repository, you will place your Kubernetes manifests, which are available in the K8 specification folder in our case. And like I mentioned, Argo CD will continuously watch for this Git repository and deploy it onto the K8s cluster. It can deploy to a single K8s cluster or multiple K8s clusters also. So we need to configure this part now. And we will also configure this part. So first, we need to connect Argo CD with our Azure Git repo. For that, first I need to log into Argo CD. So you can get the Argo CD login password. Just search for kubectl get secrets -n Argo CD. Follow these steps carefully. Some of you might not be aware about Argo CD. So you can pause the video, watch the command carefully what I'm using, and you can execute that. If the commands are very difficult, I'll also post them onto the GitHub repository, which I'm already doing. So just pick up this secret, kubectl, edit secret, Argo CD initial admin secret, -n Argo CD. So this is the secret, right? And you all know secrets are base 64 encoded. So what we need to do, we need to decode the secret. For that, echo whatever I have copied, pipe base 64 -- decode, or you can also do just -d and press enter. So this is the output that you got. Ignore the last percentile. I've not picked up the percentile, right? So just copy it from here to here. Now what you need to do, I got the admin password and the admin username for Argo CD is admin. So now I need to just access the Argo CD on the UI. For that, kubectl get svc -n Argo CD. To access it on my browser, I need to expose Argo CD, right? In the node port mode. So this is the Argo CD server, and I will expose this on the node port mode. Right now it's in the cluster mode. For that, kubectl edit svc Argo CD server -n Argo CD, and just change the cluster IP to node port. It will not take much time. It should be straightforward. Node port. You can also patch it, but I just want to show the exact change at the point. That's why I'm using the edit command. Otherwise, you can use the JSON patch as well. Let's see. It is already changed to type node port, and we got the node port as well. So I'll copy this node port. Watch carefully. I've picked up the HTTP node port, not the HTTPS. And now how do I access? Simply, I have to use node IP :node port. How do I get the node IP? Again, just do, you need to copy this password somewhere, right? kubectl, just do get nodes -o wide. And as you run this command, you will get your node external IP. So just copy this and node IP :node port. Of course, you will not be able to access because we have not opened the port in the network security group. So for that, go back to your Azure cluster, search for VMSS, which is virtual machine scale sets, because in this case we are using virtual machine scale sets. Click on the node pool and click on the instances. There is only one instance because the minimum that I set is 1. You should see option called networking. Open the inbound traffic, add inbound port rule. What is the port? This is the port that I have to open. So here, just change the destination port. Source should be any star, anyone can access our application. Destination, just check this as custom 30461, protocol any, allow, priority, yeah, that's fine. Add. Once the security rule is added, if we refresh this, just wait for a couple of seconds and the Argo CD should be accessible through the user interface. So let me copy this one more time and let me close this terminal. 30461. I hope I have opened the right one. Let's go and see. 30461. Alaf looks fine. And the node IP address is 246.110.137. Okay, looks great. Let's copy this one more time and let's try the incognito window. Yeah, so we are able to access it. I think we should be able to access it from here also. I just tried the incognito window. Yeah, it just took some time. So be patient, accept the risk and continue. So username, admin, and password that we got from the secret. We have decoded the secret and just copy paste the password. Invalid password. Let's see what is wrong. Did I copy it right? Okay, let me run that command one more time. The decode command. And let me copy this. Paste it, sign in. Yeah. So I'm able to sign in to the Argo CD console. Now to connect Argo CD, which is on my Kubernetes cluster with the Azure repository, either I need username password or I need the access token, right? Because this is a secure GitHub repository. Nobody is able to access this Azure repo. For that, what I will do is I will create a access token. Click on the personal access token in the settings button. And you need to get the access token. I already have bunch of access tokens. So what you need to do is pick up the access token with the right permission. Right permission, I mean RIGHT, not WRITE. Here, Argo CD is only downloading, right? It is only getting the changes. So technically, it is only reading. It does not need to have any write permission. So you can just pick up the access token with the read permission. But I already have bunch of access tokens. Let me use one of these things. I'll anyways delete the entire configuration. So just for the purpose of demo, we can use this access token. I hope you all know how to create access token. Just click new token and provide the name of the access token. Let's call it as Azure agent or whatever you would like to call. I just granted full access, but like I told you, you can also just grant the read access. Go back here, click on settings, repositories. If it is a public repository, you can directly, you don't even do this particular configuration. But again, to implement a enterprise level project, I have used a private repository intentionally because in your organizations, most likely you will work on private repositories. So I just don't want to show it on a public repository. Connect repo, connect using HTTPS. Yeah, Git project. This is Argo CD project. Just keep it as default. Now comes the repository URL. So for the repository URL, what you need to do is just copy the access token that you just copied somewhere, right? Let me put this in the password section for now. Or let me just copy it here, right? Copy it in a notepad in your case. And repository URL, you can just go to your Azure repo. Go to the Azure repo and click on the clone button. HTTPS, copy it. Come to your Argo CD dashboard, paste it. And what I will do is take this access token This is a very important step. And replace the help DevOps aspirants with the access token. My bad. So I need to just do it all over because I clicked on the wrong button. So git project is default repository URL. Let me copy it over the HTTPS one. I lost my access token. Anyways, I will do it again. So I copied the repository URL here. Now I'll go back and get my access token. Right? So go to your personal access tokens. So that's why it's better to copy it in a notepad or somewhere. Click on this one and regenerate. Copy it. Come back to your repository section. Replace the help DevOps aspirants. In your case, whatever is your Azure DevOps organization name, the username, with the access token and click on the connect button. You will know the connection status in like matter of seconds. If the connection status is not successful, then Argo CD will not be able to talk to your Azure repository. So the connection status has to be successful. Now the connection is successful, right? What I simply want to do, if we go back to our diagram, we have set up this part, right? Now I want to set up this part as well, where I will connect my Argo CD and deploy it onto the Kubernetes cluster. What I want to deploy? I just want to deploy this folder. In this particular case, I want to just deploy the old deployment.yaml and service.yaml. But just to show you people, I will deploy this entire K8 specifications folder. Right? Go back, click on create new application. Application name, let's call it as Azure CD. Project name default, or let's call it as OAT application because we are just doing it for OAT app. So I'll say OAT app service. Sync policy is automatic. If you select it manual, then you are not doing the CI/CD process. You have to go to Argo CD and click on do the continuous delivery, right? But I want this entire thing to happen automatically. So I'll select the sync policy to automatic. And when you select this automatic, just keep in mind, by default, Argo CD will take 180 seconds. That is 3 minutes for Argo CD to identify that there is a change in the Git and to deploy it onto your Kubernetes cluster. If you don't want to wait for 3 minutes, then you can configure Argo CD to tell it that, okay, do it for 10 seconds, do it for 20 seconds. I will choose 10 seconds. I'll show you how to do it. So sync policy is automatic. Perfect. And I don't have to change any of these things. Repository URL, you will automatically get it. You can just populate the same repository URL. Path, what is the path? Which path of your repository should Argo CD look for, right? So in my case, the repository path in your case also will be this folder called K8 specification. So just copy the folder name. K8 specification. So I am literally deploying all the manifests inside this K8 folder. But Abhishek, I want to only do the OAT deployment and OAT service. Very simple. Create a new folder inside this. Inside the K8s, you can create a folder called OAT, right? And like just as an example, you can create this OAT folder, and inside this OAT folder, you can put OAT deployment and OAT service. And what you will simply do in the path, you will just say K8 specification /OAT. But let's deploy all the manifests. Again, you will get this populated because by default, Argo CD can deploy to the same cluster where it is created. If you have multiple clusters, I've showed you a demonstration where I've deployed Argo CD. Sorry, I've used Argo CD to deploy to multiple clusters. In that case, if I just click on this option, I'll get list of clusters. Here I just have one cluster, so automatically it is populated. Namespace, you can deploy anywhere. You can deploy it to default namespace, or you can deploy that to Argo CD namespace. Which deployment it is talking about? It is asking you, where should I deploy this manifest files? I said, okay, you can deploy it to default namespace also. Now click on the create button. Now Argo CD is configured. It is already picking up everything from your Git repository and deploying it onto the Kubernetes cluster. It is doing it automatically, right? If you click on this button, you will see all the things are getting deployed. But this is not continuous delivery, right? Right now it is just configured and it is deploying. But our end goal is that I will modify something in the Git repository. Like probably I'll not modify any of this deployment files, but I'll just go to the oat folder and I will make a change to app.py, where I will just change the summer winter to, let's say, rain versus snow. And I want the image to be created, CI to be executed. The shell script, which we will write now, should automatically take that image, new image tag, and update that in the old deployment.yaml, right? This image should automatically change to Abhishek Azure CI/CD, whatever is my registry name, the ACR registry name, followed by image name, followed by tag. Then Argo CD should pick up that change and deploy to the K8s cluster. So we haven't done the entire configuration yet. But let's see if Argo CD is working fine or not. Yes, it is working fine. Now it is all set. It is saying, Abhishek, if I see any change to this particular folder, right? I am configured. If I see any change to this particular folder, I will automatically take that and deploy to the cluster. You want an example, you can change anything at this point also. Okay, so looks good. Now what I'm going to do is I will go back to my pipelines, and within the pipelines, I will write that update script. So just create a new stage. If you get any questions, you can refer to this diagram, what update stage or why I'm writing it. So just refer to this diagram, go back to the video, you will understand what update script I'm writing and why I'm writing. Basically, the update script is written to pick up the new image from the ACR and update that to the Git repository. So technically, I don't have to go to ACR and pick that new image, right? What I have to do is just I have to understand what will be the new image in the ACR, right? So if you go to the ACR container registry, identify the pattern. Okay. So the pattern is that every time if you go to the repositories, whenever a new image is created for the voting app, right? So the registry name will remain the same. Registry name is always Abhishek Azure CI/CD. Repository name is always voting app. Only thing that is changing is the tag. Once the tag is 60, once the tag is 61, if I want to download the 61 tag, see the command is that docker pull Azure Abhishek Azure CI/CD Azure ACR voting app 61. If I have to download 60, the command will be exactly same. Only thing that changes is this tag, right? So the shell script which I will write, what it needs to do is it only needs to update this tag. Repository is always the same, registry is always the same, repository is always the same, right? So that is how I have to write a shell script. Now, how do I know what this number is? Like once it is 60, once it is 61, once it is 59. Basically, this is the build number, right? So if you go to the Azure pipelines, in the last class, we saw this build ID where whenever the Azure pipeline is triggered, we are pushing the new image with this particular tag, and this tag is nothing but the build ID. So whenever you trigger the next build, the build ID will be 62. So the image is updated with a new tag called 62. So even in the shell script, what I have to do is I have to update this file. I have to update this old deployment.yaml, something like this. It should be updated with Abhishek Azure CI/CD, which is constant, followed by the repo name colon the build ID. Again, the build ID is dynamic. So this is how I have to update. So what I will do in the stage, I will say the new stage as update, display name as update, everything just call it as update. You can name this stage whatever you want. Let me just bring it syntactically right. I will also update this entire file onto the GitHub repository so you can refer it. Don't worry if you are running into any indentation errors or something. I will upload this entire file once it is ready to the GitHub repository, Day-15 folder. You can refer it. So in the steps, right, I will use a task, and the task is a script task. It is a shell script task. Click on the settings button. It will ask you what is your shell script location in the GitHub repository and what are the command line arguments. So for that, I have already prepared the shell script. If you go to the GitHub repository, in the Day-15 folder, there is this called update k8 manifest.sh. I'll explain what is in this script so that you people understand. Firstly, I'm using set -x, which is to print each and every command just to run the shell script in the debug mode. Then I am taking the repository URL, right? Because I have to update this particular repository, I need to have the repository URL. Where is it? Yeah. So I'm taking the repository URL. I'm just cloning the GitHub repository on the agent, which is running this particular CI/CD pipeline. Forgot to mention, the agent should be running. Without the agent, your job will not run. Anything that you're performing, CI, will not execute because we are using a self-hosted agent. With the free subscription, you cannot use the Azure hosted agent. You should be using self-hosted agent, which I have explained in the last class. Okay, so I have cloned the repository. Then I just copied this entire thing into the temp folder, right? I have cloned the repository to the temp folder. And then I am using the SCD command. And what this SCD command is doing, it is simply updating anything with image colon, that is this particular thing, anything with image colon. This is the original state, right? So anything that is with image colon is updated to image colon container registry name $2, $3, and it is updating the deployment.yaml file which we are asking for. Now, what is this $2, $1, and $3? Basically, what I want to do is I want to use the same shell script for all the resources. In future, if there are 2 microservices added, 3 microservices added, so I have parameterized this particular shell script. So here $2, $3, and $1 are nothing but things related to the OAuth application. In future, if I want to use the same shell script for the result microservice or for the worker microservice, I can simply update this $1, $2, and $3. So $1 is basically OAuth deployment.yaml, right? So what is changing? For the OAuth deployment, it is OAuth deployment.yaml. For the result deployment, it is result deployment.yaml. For the DB, it is DB deployment.yaml. That's why I put the deployment.yaml as same, right? So deployment.yaml is same. I'm just using the command line argument in my shell script, which provides it should be OAuth or result or DB or worker, something like that. Then $2 is my repository name, which is this one. For outing app, the repository name is outing app. For result app, repository name is result app. So this is second command line argument that I will pass. And then the third command line argument is $3, which is the tag, right? Which is this one that I was talking about, the build tag. Number 60, 61, 47, whatever is the build number, the build tag is updated accordingly. So these are the 3 command line arguments that I am passing. So the first command line argument, if I have to report repeat is very straightforward. It defines which microservice are you are using, the OAuth microservice, result microservice, DB microservice, whatever it is. The second command line argument is for the repository name inside your ACR, should be outing app, result app or something. And the third one is typically the tag that we want to use for deploying. So these are the three things. So I'll just copy this entire script, copy it, go back to your Azure repo, and in the Azure repo, create a folder. So in this Azure repo, what I will do is I will click on this button, click on new, create a folder. Let's call the folder as scripts, and let's call this script as update K8's manifest, update K8's manifest dot sh. Paste the script in your Azure repo. So I have copied it from Day-15 folder and I have pasted it in my Azure DevOps repo. Change the access token. We can use the same access token because I have granted full access. If you want to use access token with specific permission, which is definitely something that you have to do, you should not grant the full access. But because this is the demo, I'm just using it to save time. And if I go to my applications, I can just copy it from here. So let me go back. So here I will place my access token. You have to place the right access token, and also in your organization, whether let's say you want to keep it more secure, because storing access token in a Git repository is not safe. So what we can do is we can also pass this access token as one more command line argument from the CI pipeline, and CI pipeline can read it from the environment variables, right? That way we can make it secure, but the demo will become a very lengthy one and it will become very complicated. So that's why I'm using it here. But if you do it in your organization, what you will do is you will take this access token as a command line argument and you will read the access token from the environment variable. I will show it sometime. But yeah, for now, the access token is here. The repo name, perfect. Now we got the repository name. Repository will be cloned. Then we will move to the temporary directory where the repository is cloned. Then the container registry name. In my case, what is the container registry name? Abhishek Azure CI/CD. $2, $3, which are command line arguments. I am not changing any of them, and I will commit this file. Perfect. The file is also committed. Now, all that we need to do is go back to our Azure pipeline, right? In the Azure pipeline, provide the path as scripts update K8's manifest dot sh arguments. So 3 command line arguments. The first argument is ought. Why ought? Because if you look at our script, what it is doing, it is saying $1 deployment.yaml. So it should be ought deployment.yaml, result deployment.yaml, something like that. So that's why I will pass the first command line argument in this pipeline as ought. The second command line argument is my Azure repository name, the ACR repository name. So I will take this as outing app, and I don't want to copy it because there is already a variable that I've created for that, right? So this is the variable which is called as image repository. So I can simply do $image repository, and the final one is the tag. So I can simply do $tag, and you will see how will this script change this particular file, right? Not this one. So right now this file, the K8 specification, ought deployment.yaml, right now it has Docker samples, something like this, right? When I execute the next pipeline, you will see this particular file will be updated. We will do that in a second. Just click on the add button, go back to this particular line, and click on the add button. Now you can remove this task line and just update it accordingly. Cool. So let me save this and execute. Now, when I run this, like I've told you, you will see a new stage called update. And the responsibility of this update stage is that it has to update this particular file, the deployment file that we are seeing here, to the new container image with the new tag. If you go to the pipelines, now the pipeline is triggered. And if you watch carefully, the pipeline is triggered with the new build number, right? The image is getting created and image is created with the new build number called 62. Now it will go to the push stage, and within our artifactory, if we go to this registry, we should see a new tag with 62. Let's wait for it. Push is going on. It will be performed, I think, in matter of seconds. Yeah, I think the push is also done. Now if we go back and refresh, we should see a new image with 62. Build stage is successful. Push stage is also successful. Now we are going to the update stage. Let's see if the update will also be successful. If there will be any issues, we will try to fix it. So the shell script is running. It is checking out the shell script. Now the shell script is running. Okay, shell script is also run successful, but let us see if the shell script has updated the configuration or not. If we go back to the deployment.yaml, and if I just refresh this page, I should see this updated. Okay, it got updated, but there is some issue here. It said Abhishek Azure CI/CD, and here if you look at the parameters, it passed the command line arguments as is. The variables are not converted. So there should be some issue with our script. Let us see. If we go back to our script update kh.sh. So, okay. So this is fine. It is picking up the parameters, but in the pipelines, I think we are not passing them correctly. Oat service. Let's go to the pipeline from here or from the repository. Let us see if I missed something. I think I can place this one. Probably it will work. Let's see. I think this should be much better. I'll give it one more try. These are very simple microservices, so it is taking very less time for the build, push, and update. In some cases, it will take a lot of time where you can run an individual stage also, right? In Azure pipelines, you can also individually run a particular stage if you want to just verify something on your test pipelines or on your build pipelines. I hope this will be completed soon. So the build is in progress again. Cool. One more thing is that Argo CD is watching for this change. So the new change will also be deployed at this point of time. Only thing is we have not configured Argo CD for 10 seconds. By default, it is configured for 180 seconds. I'll make that change and I'll show you. But it is important for the shell script to work. Again, a new image is pushed. So if we go here and refresh, there will be a new image called 63. Cool. Update script, invoking. Okay, it again updated, but let us see if it updated properly or not. Last time there was some issue, right? So if I go back to the oat deployment.yaml one more time. Cool, it updated the image to 63. So every time a pipeline is run, this image is updated. If you run it one more time, it will update to 64. If you run it one more time, it will update to 65. Meanwhile, Argo CD is watching for this repository, right? So let us see if it identified the change or not. If I click on the refresh button here, it is still refreshing. So the last change was about an hour ago. Probably did not identify. Like I told you, it will take 3 minutes by default. But what we can also do is we can go here and update the Argo CD sync time from 3 minutes to 10 seconds. For that, you just have to do this kubectl edit cm Argo CD cm. There is a config map. Because I work with Argo CD on a day-to-day basis, I know these things in much better way. Don't worry, like you need to get used to this. Data, we will add something called as timeout dot reconciliation. I hope the spelling is right. To 10 seconds. Abhishek, how do I understand this? If I am new to Argo CD, you can go to the GitHub page. Let's go there. So Argo CD docs, and you can just search for this timeout reconciliation. Timeout dot, yeah. So this is a setting. Timeout dot reconciliation. I hope the spelling is right. So I'm just changing this to 10 seconds. And once I change this to 10 seconds, from next time Argo CD, if you can change it to 2 seconds, 3 seconds also. But the problem is that when there are so many changes at once, then it becomes difficult. Right? So let me refresh this. Do not set that to 2 seconds, 3 seconds, because in ideal cases, that is in real time, where Argo CD is working with a lot of microservices, it will become very difficult for Argo CD. Okay. I think we are using the wrong URL, right? Let us see what is wrong here. It's still refreshing. Is this the right IP address? Let me go to my Kubernetes cluster and verify very quickly. So the shell script part is done. Now I'm just verifying the Argo CD part. Oh, this is the Argo CD, right? I'm looking at the wrong cluster, which we have used for the preview purpose. That's what I was wondering. So this is my cluster, and see, it said the sync is successful, and it just did it. 1350, and the time is also 1350. It just performed it, but the pod is not up. Okay, it said it has updated the image. So Argo CD did it part. If you go to kubectl edit pod -n Argo CD, and sorry, let's do kubectl get pods -n default, or just a regular one. See, the oat application is deployed. And if you go to the oat application again, kubectl edit oat -n Argo CD. Sorry, it's in the default namespace only, right? Kubectl edit pod, this one, you will clearly observe the image is updated, like the container image is updated to Abhishek Azure CI/CD outing app 6.3. But Abhishek, what is the problem? Then why is the image showing image pull error or error pull image? Error image pull. Any guesses? You can pause the video here and try to guess. If anybody guessed it right, basically this is because we are pulling the image from a private registry. Now, how will Kubernetes understand what is the secret? What is the username and what is the password? So Azure Container Registry is within my Azure repo. Kubernetes does not have the ID of it. So how will it even understand? For that, we need to use a concept in Kubernetes called image pull secrets, right? So image pull secrets is the concept that we will use. And using this image pull secrets, we can pull images from the private registries or private repositories. For that, again, you need the password. So what I will do is go to the Azure Container Registry, click on access keys. You can also use the, what do I call it? The service principal. But in my case, I'm using the access keys again, just for the quick reference. But if you are doing it in your organization, either use access keys with defined permissions or use the service principal. In your case, you might be seeing something like this, right? Just enable admin user and you will get the admin user as well as the password. And go back to my GitHub repository. There is this command called create ACR secret. You can just copy this command. In my case, I already have it handy. So kubectl create secret. So what are the things that you should know here? Namespace should be the default namespace because our pods are deployed in the default namespace. Secret name, you can put anything. In my case, I'm using the secret name as ACR secret, right? So better you also use ACR secret. Namespace is default. So set the namespace as default. Docker server, the container registry name. What is the container registry name here? In my case, the container registry name is Abhishek Azure CI/CD, right? So that's why I set the container registry name as Abhishek Azure CI/CD.azure.io as mentioned in the command .azure.io, Azure ACR.io. Then Docker username and Docker password. These are the things that we will take from the username and password section. Use password and use the username, this one. So I have these things. Let me copy the password. kubectl is perfect. Create secret, right? So I'll just change the password here. Probably the password is updated. This was the command that I was using previously. And once this is done, I think we are all set for performing the demonstration as well. Everything looks good now. Cool. So the secret is also created. All that I have to do is go back to my deployment.yaml, edit the deployment.yaml, and add something called as image pull secret, right? You can also get this from the Kubernetes documentation. Like if you are not sure about this, just say Kubernetes docs image pull secrets. So pull an image from the private registry. Just go to the, just scroll down. You will have a section. Like just copy this one. It should be in line with the container section. So I'll just go back. What is this? So image pull secrets. I can just copy it, match it with the containers section. And what is my image pull secret? ACR hyphen secret. I hope that is correct, right? ACR hyphen secret. Perfect. Commit this change. And now for the demonstration, just commit it one more time. Okay. Refresh the file. I think the file is already open, so it is complaining about the change. Edit. ACR hyphen secret. Commit. Looks good. Now the image pull secret is also fine. Looks great. So to verify the CI/CD, what I will do is I will go to the OAT. I will go to app.py and let me change this to rain. I'll change this to rain and I'll change this to snow. Commit. Now the pipeline should be triggered automatically. I will not be changing anything. So the pipeline is triggered and let's wait for all the changes to work, right? My CI and CD, everything should work now. So the build stage, push stage, update stage, and even my Argo CD. So if I just go back in the Argo CD screen, right? Just to show you, all of them will trigger automatically. See, right now the pod is crashed, but because the image pull secret is updated, I want Argo CD to identify that change automatically and work without any manual intervention. So let's go back to our pipeline stage. Where is the new pipeline? Yeah. So the build is done. Now the push is taking place. So I think the push is also done. And let's go to the build stage and see what is the image. So the image that got pushed is 64. The image that got pushed is also 64. If you go to container registry, we should see that in the repository section. Go to the OTR app, voting app, and the 64 image is also available. And my shell script, I hope it has updated the oat deployment.yaml. Yes, it is updated to 64. Now finally it is left with Argo CD, and Argo CD will take some time here. I will explain the reason. Typically, the previous state was the pod was crashed, and there are multiple replica sets that are available with Argo CD here. It's a unusual case, but it will handle automatically. All that you need to do is just wait for a minute or so. From next time, the changes will be updated within 10 seconds. Right now, we put it in a exceptional case where there are multiple replica sets, and in one of the replica set, the pod is also failed because of the error image pull. I'll not change anything here. I'll go to the cluster and I'll just wait for it. kubectl get pods minus W. Okay, so image pull back off. This is the new one with 5 seconds. Let us see if this is the new one that is published. What is the image name? Okay, the image name is 64 and still it is showing image pull back off. Permission denied. Insufficient scope, authorization failed. Okay, let us check that there is no problem. kubectl edit pod. Let's go to the pod that is newly created, right? Minus, okay, it's in the same namespace. Is the pod created with image pull secrets or not? Let's see. Do we have the image pull secrets in here? Let's search for it. Image kubectl edit deploy oat image pull. Okay, image pull secrets is available and it says image pull secrets as ACR secret. Is the secret available? kubectl get secret. Okay, we created secret in the wrong namespace, I guess. Let me verify my command. kubectl create secret. Okay, it created in the Argo CD namespace. That's the reason. Should be a very simple issue. Minus n Argo CD, right? Let me just remove that change. So I'll just remove this and now the secret is available, right? Now the deployment should be working fine. Now if I just do, we don't have to change anything in Argo CD or any other place because the pod will automatically pull the secret. kubectl get pods. So if you just do kubectl delete pod, the existing one. Now the CI/CD is successful. There is no issue with that. Only that the image pull secrets was not available on the cluster. So we will wait for the new image pull secret, the new deployment to pick up the image pull secret. Still says image pull back off. Let us see what is happening. kubectl get secret. Okay, the ACR secret is available, but still it says error pull image. Okay, we actually did a very silly mistake. If you look at kubectl get deploy oat minus o YAML, so everything is fine. Our CI is fine, our CD is fine. The mistake is that if you look at the deployment, it is updated with the image pool secrets, ACR secret. But if you look at the image name, it is Abhishek Azure CI/CD outing app 6.4. But actually, the image is something different, right? If you go to our ACR, the image, the registry name is actually Abhishek Azure CI/CD dot Azure CR dot IO. But in the image, we updated it wrong. So what we will do is we will correct our script. So this should be issue with our the pipeline where we are passing this value, right? So what I will do, the currently port deployment.yaml is updated with that particular image name. So either we can fix it in the script or we can fix it in the pipeline, right? This is our shell script. We can also update it here where I can simply say Abhishek Azure CI/CD dot edit this. So after editing this, I'll re-trigger our CI/CD by making a different change, and let's verify if the complete CI/CD is working fine or not. So these are some kind of issues that you will run into. Can be silly ones, but it will take some time. What is that? It's Let's copy this so that we don't miss it one more time. Now it should be good. Abhishek Azure CI/CD dot Azure CR dot IO. So I'll commit this change, and so this change is made to the script. Now let's assume that I am a developer and I am making a change to verify the CI/CD process, if the CI/CD is working end to end or not. So I will change these options, rain and snow, right? Let's give a different option so that we are confident about our CI/CD. Let me say, let's give some options like, let's call Docker or yeah, let's use this Docker Swarm Kubernetes. So which container orchestration is the one that you would prefer? Options are Docker Swarm and Kubernetes. Let me commit this change. So developer has made this change and our CI/CD pipeline will trigger automatically. It's running, and I hope my runner is also active. Let me verify that. Yes, my runner is also active. So the build process would have started. This time I think I'm confident that the CI/CD changes will work. CI/CD changes are actually working. I mean to say, this time I'm confident that the end-to-end thing will work because I've updated the script also. And now the secret is also good, image pool secret. So build is done. We push the new image with tag 65. Yes. And push is in progress. So it will push the 65 in a while. Looks good. I think it pushed 65 also. Let's go to our voting app, refresh and see if 65 is available. Okay, let's go back. Repositories voting app. Yeah, 65 is also available. And shell script is also updated. Let's go to our repos and see if shell script has updated this value to 65. So I'll go to K8 specifications or deployment.yaml. 65 is updated and this time it is Abhishek Azure CI/CD dot Azure CR dot IO voting app colon 65. Now rest is left to Argo CD. Let us see if it is doing the magic. So let me refresh this page and see if it is picking up. It will take some time, like I told you. So if you don't want to wait, you can click on the sync button, but let me wait and allow Argo CD to pull the change. So let's refresh and see if it has pulled the new change. Okay, so I think it is picking up new change, and I hope the image is 6.5. healthy, right? So it deployed 65. Awesome. From next time, it should work very fast. I have changed the timeout reconciliation also to 10 seconds. Otherwise, just wait for it to complete. So now Argo CD has pulled the change. Let us go to the cluster and see if it got deployed. Now I'll run the same command, kubectl deploy oat minus o YAML, and the image should be 6.5 on the cluster as well. Yeah, so image is 6.5 on the cluster. We can also see kubectl get pods. It should look good. Kubectl get pods. All the pods should be in running state. Awesome. So now it's time to access this service and see if the new options are Docker, Swarm, and Kubernetes. For that, kubectl get svc. So the oat service is running on 31,000. And what is the node port? Kubectl get node minus o YAML. Oh, my bad. Minus o wide. I need the external IP address. So this is the IP address and 31,000 is the port. So IP address colon 31,000. So obviously, just like Argo CD, even this won't run because we need to open the port. For that, I will go back. We're almost done. Let's go to VMSS. And in the VMSS, let's go to the node pool. Let's go to instances, networking, and add 31,000 to the port. Add inbound port, and let's add 31,000 here. Once you add it, just wait for like, let's say 30 seconds, 1 minute, because we just updated the security rules and it will take some time. So I will try my luck again. Let's wait for 10 more seconds. This should update automatically. You don't have to do anything. We just updated the network security. So we will wait for the changes to reflect. All that you need to do is just verify that you have updated the right configuration. That's it. This is the previous one. Let's go. And let me reevaluate 31,000. Yes. And is the kubectl get svc? 31,000 is the right port, I assume. Yeah. Oh, awesome. Now it is updated to Docker Swarm Kubernetes. So I just implemented CI/CD for the oat service. Now you can imagine how much time it has taken. So if I have to do same thing for results, again, I have to spend a lot of time. But for you, it will be easy because I have updated the scripts, I have updated the file, and you also have the video. So if you have time, you can sit and implement the result service as well. And let me know if you have implemented the result service in the comment section. But at least try to implement this part. We have covered a lot of concepts in this video. We have learned about GitOps, we learned about Azure pipelines, we learned CI/CD end to end using day 14 and day 15, last video and this video. We learned about image pool secrets, AKS. So a lot of learning in this particular class. So I hope you enjoyed it. Thank you so much for watching, and play with the CI/CD, right? Give another options and see if the end-to-end CI/CD is working fine or not. Thank you so much. See you all in the next video. Take care, everyone. Bye bye.